In the last video, we saw how signals can be represented using math. But here's something interesting. Not all signals behave in the same way. Some are smooth, some are broken into steps. Now here's the real question. How do engineers make sense of all this? They classify signals. Because once you classify a signal, you know how to work with it, you know how to analyze it, and how to process it. Let's start with the first classification based on time. A continuous signal exists at every instant of a time, like temperature changing throughout the day. On the other hand, a discrete signal exists only at a certain point, like measurements taken every second. So the difference is not in the value, it's in how often signal is defined. Now there's another important classification, this time based on value. An analog signal can take any value smoothly, but a digital signal can only take specific levels like zeros and 1. So here the difference is not time, it's the type of value the signal can take. Now here's where things comes together. A signal can be continuous and analog or discrete and digital. For example, your voice in real life is continuous and analog, but once it's recorded in a computer, it becomes discrete and digital. Now you might wonder, why do we convert signals into digital form? Because digital signals are easy to store, easier to process, and more resistant to noise. It's not just about energy, it's about reliability and control. Now that we understand different types of signals, the next step is to see what happens when a signal interacts with system, because that's where engineering really begins.